All right, good morning. I just want to take a moment to go through these notes in case you missed these in class. So what we're talking about is surface tension. We addressed this a little bit yesterday, and what surface tension is really the attraction. It's also a form called cohesion. But it's the attraction between molecules in certain substances, water being one of the key ones that we're going to look at an example of. And so what's happening is we're trying to figure out what's going on at the surface of a liquid. But to do that, we got to get small. Let's get small. So all these blue dots represent particles of water. Now in a liquid, we know that these particles are constantly moving. They're constantly moving randomly around each other. They're randomly arranged. And that's the case. You'd expect them to have a kind of a rough surface, a bumpy surface, where these things flow around each other all over the place. So, but when you look at a calm lake, if there's no wind, or you look at a pond and there's no wind, it doesn't look like this bumpy surface. We don't get that kind of rocky surface unless wind is causing it. So what we normally see is a flat surface. And the reason we see that is because of what's called intermolecular forces. Very fancy word for saying forces between molecules, intermolecular. So water is a polar molecule. Water has a positive side. Water has a negative side, kind of like a magnet. That being the case, the positive side of one water molecule will be attracted to the negative side of another water molecule. That's that kind of intermolecular attraction, that stickiness that water can have. So under the surface, these intermolecular attractions, all these water molecules are pulling on each other in equal force. They're pulling in all directions. However, if you look at the top, there's water pulling on the left, the right, the bottom, underneath, but there's nothing pulling upward because there's no water molecules there and there's no attraction between the air molecules above it. So what's happening, if all these things are pulling down and to the side, what's going to happen is this little bumpy curve is going to naturally flatten out. So that compression is going to cause those water molecules to flatten out. And that's when you get that skin on water, that flat surface, whether it's a glass of water or a pond or a lake. Surface molecules are a nice flat surface. This is why when you dive in, it's important that you don't just hit flat because you're going to break the skin, and that's going to hurt a little bit because it has a little extra force to it, a little extra attraction to it. This is also why water drops are round. If you think about it, all these water molecules are pulling on each other. All these molecules in the middle pull on each other equally. There's nothing pulling on the outside of these water molecules. Because there's nothing pulling on the outside of these water molecules, they're all drawn to the inside. This is why water droplets appear round, because all that forces, all the intermolecular forces are pulling them to the inside, creating a perfect sphere. Okay, so that's how water drops are water drops. Water has a really high surface tension. The reason that it has a high surface tension is because of that polarity of the water. It has a positive and negative pole to it, kind of like a magnet. So when you get water together, those positive and negatives stick together. And it's just another form of attraction. If you've ever seen a water strider, this is a bug that can actually take advantage of that surface tension. If you look by his feet, you can actually see where the water is bending under his legs. He's distributing his weight on a flat surface. We're actually going to show you something like that today in the lab. Where we can actually balance a paperclip, which is much more dense than water, but because of the property of surface tension, and we take advantage some balances properties, we can actually float a paperclip. All right, those are the notes on intermolecular forces. We're going to go through that in the Google form as well, but I just wanted to make sure that you had a chance to hear those notes if you weren't able to see them. Hopefully that helps.